So, hi everyone, and first of all, thanks for joining the LocalStack community event. So, we have been organizing these community events for well over 6 to 7 months right now, and it is super great to have all of you once again because it's a new year totally, and we are back with some like whole lot of new initiatives and new things that we are going to talk about. So for this community event, we have two different talks, and we will be talking about how you can deploy locally with Terraform and Cloud Pods. And our senior engineer, Joe, who has been working on Cloud Pods for quite some time, he will be discussing about how you can set up Terraform for your infrastructure as a code lead and how you can use LocalStack to pretty much test these Terraform modules pretty much locally itself, and how you can use Cloud Pods to save all of your local infrastructure so that you can easily share it across with your team members or even use it for different use cases like preceding your CI environments or creating some reproducible application samples and more of that. Apart from this, I will be taking a separate session, which will be entirely focused upon the LocalStack Docker Extension. It has been a new tooling that we have released out in collaboration with Docker, and it pretty much provides a very intuitive user interface through which you can control your LocalStack container pretty much locally. And you can also do a ton of things with this. And we are going to demonstrate some super cool application samples that we have been developing for the past few months. And I guess most of you are excited just as we are. So to kickstart this, I guess I can mention that this meetup will be recorded and it will be available on our YouTube channel. So if you have not subscribed to our channel before, please do that. And we will generously like acknowledge all of the subscribers that are joining us over there. And we will completely anonymize the recording. So all of your identities are completely safe with us. Cool. So before we jump into the like speaker sessions and the audience participation and all of the other things, I guess, Waldemar, can you please take up a few moments so that you can talk about some of the highlights that we have achieved in the past year and what is the upcoming roadmap for this year itself? I guess that would be super useful to communicate this with our entire community.
Yeah, thanks so much, Harsh. So just a few words to set the stage. I'm not taking too much time, but I think we can look back at a really successful year 2022 and an even more exciting one that's coming up in 2023. So ever since we released our version 1.0 release in July last year, we had a really great uptick from our community. And I want to also take this opportunity to thank all of you for participating in last year's Hacktoberfest maybe, or just continuously creating issues and then also pull requests in our repository. So really great engagement from everybody, and big kudos out there to the community for really making this a very active community-driven project. So we have lots of new features and significant enhancements that we put into LocalStack over the last couple of months. So we continue to invest very heavily in AWS parity. So we have our own frameworks for making sure that we have very high parity in terms of our implementation with the real cloud. We've put out the Docker extension, first version that Harsh will present shortly. We're very much focused on Cloud Pods, which we'll see from Joe in the presentation later on. And we just see there's a lot of uptake in these new enhancements and things that are coming out. And we're currently working towards our version 2.0 release, which is scheduled for end of this quarter. So you can expect some more announcements and concrete dates coming up over the next 2 months. So tentative date will be end of March, but more details to be coming. But just as a sneak preview, there's going to be an all new Lambda provider, better support for Kubernetes, so running LocalStack on Kubernetes. We're also working on reducing and optimizing Docker image size more and more, have an improved CLI experience, and many more features that are about to come out. And generally, our focus in the upcoming months and this year will be a strong focus on value-add services and the whole ecosystem around LocalStack. So further focusing on enhanced IDE and debugging integrations. So we already have a blog post and a few samples of how you can use, for example, your Visual Studio Code IDE for debugging Python applications, for example. We're going to be investing much more in this area as well. We're going to be pushing for LocalStack extensions, which is our way to plug in new service emulators into the platform and also provide cross-cutting functionalities across LocalStack. We put out a POC for a Stripe emulator, for example. We're working with Cloudflare on some integrations. So extensions is really something we want to put a lot of focus on over the upcoming months. And then finally, very important point is just focusing and doubling down on next generation use cases for Cloud Pods, using it across the CI pipeline and really helping you gain end-to-end insights across your pipeline. So this is really some of the highlights and, or sneak preview of things to come. We're really looking forward to working with you all. We have our Slack community. Always great to get your feedback there. We have a GitHub issue and the various ways to interact with us, but maybe Harsh is actually going to share a few more details towards the end about how you can reach out to us. So with that, over to you, Harsh, for the community Slido.
Awesome. Thanks a lot, Waldemar, for highlighting all the achievements and all the things that we have done in the past and some of the upcoming things that we're really excited to work upon. Cool. So before we actually jump into the speaker sessions, we actually want to know a bit about you and the kind of aspirations you have from LocalStack. So for that particular purpose, we are going to be using Slido for this. It's a community platform through which we might be able to ask a few questions. And we're also going to use it for our integrated Q&A. So you don't have to post all your questions on the Google Meet because things usually get lost in that, in the plethora of messages that are coming about. And you can post all of your questions over here itself. So if you have never used Slido before, you can just go to slido.com and you can particularly enter this code over there that will allow you to join our Slido session. So all that you need to do is to just go to slido.com, maybe enter this code over there, and you will be basically a part of the whole Slido session that will be happening over there. So I guess I can share the Slido session itself because this is where all our questions would be seen. And there is also this QR code, which you can particularly scan through any of the QR scanners that you might be using, and you will be directly part of the whole Slido session that is happening. Cool. So for this slide, we just have a very few basic questions that will help us set the context for this meetup. And it will also help us understand what kind of audience we are dealing with and what are the particular expectations you might have from LocalStack in the coming days. So it is mainly focused towards your usage of the Docker desktop, Docker extensions, about your ISE tools, because this particular meetup is focused a lot upon Terraform. But in the future meetups, it might also be like, it might be also be helpful to talk about the other ISE tools in the market. Like we have got Pulumi, we have got CDK, we have got CloudFormation, and more of that. So with this, I hope most of you have joined the Slido. Is there anyone who has not joined it yet? Or anyone who has like, do we have folks like who have joined this Slido session already? Can I just get a quick yes? Cool. I guess most of you have joined over here. That sounds pretty great. Cool. So I guess I can start this whole Slido session right now. And the first question is pretty simple. Have you used Terraform before? Because I guess Joe will be giving us a very basic introduction to what Terraform is. And he will walk us through like how to write some basic Terraform AWS modules. But it would be interesting to know like if there are some people like who don't exactly know what Terraform is, or maybe they have not worked with Terraform before. Cool. I see that we have some significant participation. Most of you know what, like how Terraform works out, and you might have like worked on with Terraform before. Do we have anyone who has worked on with Terraform plus LocalStack? Because we have this whole wrapper script that we recommend to our customers, like who want to use LocalStack alongside Terraform. Do we have anyone who has used that yet? Maybe you can give a quick yes on the chat if anyone has. Awesome. I guess there is a pretty dominant point of view towards people like who have actually used Terraform before. I guess we can jump to the next question, and it is more focused towards your usage of Docker extensions. Cool, that's great to know. Yep. So have you used Docker extensions before? So Docker extensions is pretty much a new feature that has been related, like rolled out by Docker, I guess the last year itself with DockerCon. And there are a lot of companies who are actually building different extensions that might allow you to use their toolings and products quite intuitively. So there are a lot of things present over there, which I can possibly demonstrate once I am talking about LocalStack's Docker extension and how it easily plays out while trying to control your LocalStack container at the end of the day. Cool. So I see that a lot of people have not used Docker extensions before. There are some people like who have used it as well. Anyone who has used LocalStack's Docker extension yet? So Vincent, I guess that's definitely a sentiment. Docker Desktop seems to be a paid product. Like Waldemar, I guess Docker Desktop is free for the community as well to use. Like this is what I practically know.
Yeah, that's right. We did have, so currently we're still pretty much building our stack on Docker, but we did have some requests for using Podman or other sort of containerization platforms, which I think we're also going to be looking into more and more over the next couple of months to support those as well.
Exactly. So Vincent and Pratik, I guess if you're not like focused towards Docker desktop, we still have like another product that is called as LocalStack Cockpit. We just did like a major release on that part to basically update its branding and make sure that it is updated with all of the LocalStack like engineering efforts. So if you're not focused towards Docker desktop, maybe you can give Cockpit a run because it provides nearly the same functionalities. And we're trying to build our desktop application even further as we progress with the time. Yeah. Cool. I guess we have just one last question, and it's about like what other ISE tools have you been using apart from just Terraform? So if you have been like using CDK, CloudFormation, Pulumi, Serverless framework, you can just mention about that. Awesome. Waldemar, I believe like we have seen very less adoption on the Pulumi side, but it seems like there are a few users who have been using Pulumi.
Interesting.
Awesome. Cool. So these were some pretty significant insights. So thanks everyone for participating in this. So I'll close the Slido now, but it will still be open for all the Q&A. So if you have got any questions or if you need to ask anything out, please just join the Slido session and put out your question, and we'll be more than happy to clarify like some of these things out. Cool. Pratik, yes, thanks for the feedback. Maybe I'll try to set something up for the next time itself. But yeah. Awesome. So I guess, yeah. So the agenda for today's talk will be quite simple. First, we are going to have a speaker session from Joe, and he will be talking about deploying locally with Terraform and Cloud Pods. So he will take the liberty of like explaining a bit about Terraform and what it exactly does and what this entire infrastructure as a code paradigm exactly is, and how does LocalStack play out with it before he moves to the presentations and the demonstrations, which can exactly showcase to you like how you can test out really complex Terraform AWS modules within LocalStack and how you can save the infrastructure state using Cloud Pods itself. The second agenda would be talking about LocalStack with Docker Desktop extension. And even if you're not using Docker Desktop, you can get to see like how LocalStack is providing you a visual means to basically control your container. And you can translate the similar lessons to like even using our own desktop product, which is the LocalStack Cockpit. So that's pretty much for the introduction part. So thanks everyone for joining. And I guess I can give the stage to Joe, who will be really interested to like demonstrate his projects and his demonstrations over here. So yeah, over to you, Joe.
Thank you very much, Arsh, for the intro. Let me try to share my screen with you guys. I hope you see the screen. Yeah, so as Arsh said, today I'm gonna talk to you a bit about Terraform and briefly starting to explain what Terraform is. I mean, we saw that some people didn't use it so far. And then we are going to try to showcase a bit like what's Cloud Pod. It's one of the features we are heavily working on LocalStack at the moment. And they have some, let's say, connections with Terraform for being like a technology that's used to snapshot states and to basically encapsulate the states of your LocalStack resources. So there is some kind of like parallelism between the two technologies. And I want to start like from a very basic like Terraform example, and then building up like to more complex application to show you how easy it is to deploy locally Terraform applications with LocalStack. So brief intro about Terraform. So Terraform is like an infrastructure as code tool. What it means that you basically define your resources in a declarative way. So you write them down as a code, and then basically what the tool does, in this case Terraform, but there are other tools like Pulumi, for instance, we saw before in Slido. What Terraform does basically reads your infrastructure as code scripts and creates a plan for what it needs to be done, and basically try to create the cloud resources that you specify in the way you specify them. And this is very powerful for a couple of reasons. First, like that's code, so you have all the advantages that you have with code. You can put that code in under source control, so you can like have it on GitHub, for instance. You don't need to click through your AWS console to spin up resources and to keep recreating some states that you want to have in your application. It's easily replicable. It's reliable, and so offers like a lot of advantages to try to declare resources in this way, to manage resources in this way. And so to use Terraform, you can interact with the Terraform CLI commands. But as Arshan, I think, mentioned before, we have like a wrapper around this Terraform CLI command. That's our TF local script that basically helps in configuring all the endpoints. So we're going to see in a moment. So when you run like a Terraform module, of course, you don't want to talk to the real cloud if you want to deploy to LocalStack. So you need to talk to LocalStack. So you basically will need to specify the LocalStack endpoint for all services. So you basically will need to say, okay, I want to spin up a SQS. So I need to specify the SQS endpoint with HTTP, localhost, port 4566. And instead of like writing all those endpoints manually, you can just use our wrapper tool, and this is done automatically. I will show you a small example in a minute. And then like we first play a bit with Terraform, and then we start showing like Cloud Pods. I said that there is like a sort of like they go in this kind of same direction, because with Terraform you want to be able to deploy like a state in a reliable way. So like starting from code, deploy a state, and Cloud Pod like try to tackle like a similar problem if you want. Because basically what Cloud Pods do, they take snapshot of your LocalStack instance, so your everything that's in your LocalStack container at the moment, and take a snapshot and store it for later usage. And it's still a way to replicate state, to work with state, but it has like additional power, because you can take the state, you can distribute it, you can share with colleagues. So it enables basically collaboration for cloud application with colleagues. You can collaborate on state in LocalStack. You can use pods to precede test environments, and you can actually debug cloud application easily with the usage of Cloud Pods. We're gonna show like a couple of examples. But let's jump into some small demo. And hope you can read my terminal. Well, it's not too small. So first thing I want to do, I want to start to create like a very small Terraform module, and try to deploy it on LocalStack. So let me start with LocalStack on my machine with the LocalStack start command. So LocalStack now is starting, and let's open VS Code, and let's create like a Terraform module. So to create a Terraform module, you just simply need to create like a .tf file, and you need to start writing down the resources you want. So Terraform calls providers the module for different like cloud resources. So in our case, we want to use AWS as a cloud provider. So we need to specify provider AWS this way. So this is like, it's called HashiCorp language, configuration language, ACL, and it's a way to declare your resources in basically Terraform. So we specify the provider we want to use. We could, for instance, specify the region. And now we want to have US East 1. And then we need to basically tell Terraform which kind of resources you want. And to specify resource, you need to create a resource block. as you see, I've in research to the code, I have like this Terraform extension. So it gives you like auto completion. It's pretty nice. It's pretty easy to write like some Terraform modules. So for this small example, let's say I want to create like I don't know, SOS queue. So I declare a resource in AWS SQS queue, and I give it a name. Let's say we call it meetup queue. That's the name of this resource. Then I need to give a name to this queue. Let's see, like in here, if you see, auto completion gives you basically all properties you can attach to a queue. And this is like super nice if you are writing resources, if you're doing resources from scratch. And let's say I want to create a queue. Let's call meetup queue. Okay, this is our like Terraform module. So if I try to basically deploy this will basically won't eat LocalStack, but will eat like the real AWS cloud. And of course, we don't want this. So we want to basically eat LocalStack. So ideally, we will need to create like a endpoints configuration here and specify SQ. And we will need to tell the endpoint it will be LocalStack on port 4566. But we cannot totally avoid this if we use our TF local script. I can show you how to do this. So let's go where the file has been declared. So this is our Terraform configuration. And let's initialize the Terraform project here. So if you run tf local init, what this does basically, it initialize the provider, the Terraform provider. So Terraform provider is the actual code that deals with talking to the AWS and to deploy resources for us. So this has been initialized here. You see like a .terraform folder where the module is. And now we can try to call a tf local plan. And this should basically tell us like what we are about to create. Let's look at the output. So basically, Terraform wants to use this provider to the AWS provider to generate this resources here. You see that we have like a queue called meetup queue that's going to be created, and it doesn't know yet what's the R, and it doesn't know yet like a lot of information because it needs to create first the queue. But it knows that it's going to be called meetup queue. So to now try to run this, to execute this Terraform module and actually create the queue, we need to run Terraform local apply. And this will try to apply this configuration and create the resources. We need to confirm that we want this to be created. So we type yes. And ideally, if you look at the output in LocalStack, you see we are creating a queue. And it takes like a bit, but yeah, the queue has been created. Basically, we can see the output in LocalStack is like making sure that the queue is there. Let's wait for a couple of seconds more. It's doing its magic in the background. And okay, it says that the queue has been created. It took like 20 seconds. Let's try to make sure that queue is there. So we can list our queues. And okay, we see that our meetup queue is there. So we are able to deploy our module. And Terraform is also super nice because it doesn't only allow you to easily create resources and in a very replicable way, because you can run this script like over and over and the state will always be the same. But like, for instance, also helps you to destroy resources. Like we could Terraform destroy, and basically all the state will be destroyed automatically. So you don't need to take care, if you're playing with something and you want to kill it out, you don't need to take care of like deleting resources like one by one. You can just call Terraform destroy and all resources will be destroyed. Okay, we can now stop LocalStack to some fresh state in there. This was the like first small example on how you can create basically Terraform states in LocalStack and can deploy them locally. I want to jump like to a second, a bit more complex example. Should have like a slide showing the example. So this is like another small application. This time is a bit more, let's say, a bit more engaged. It's not just creating a queue. This is like a small application tutorial that you
yeah.
You
Sorry
see it
for
again?
the trouble. Yeah.
No worries. So this is like a sample application you can find on the AWS docs, where you basically you have like a S3 bucket connected to a Lambda function. And basically what this sample does creates thumbnails of images that you put on a bucket. So you put an image on a bucket, Lambda is triggered with the S3 notification. This image is taken from the bucket, resized to a thumbnail and put into another bucket. And we have like a Terraform, a module that does that. And we are also this time like see in action Cloud Pods to do the same thing. So let's try to have a look. So let me restart LocalStack. LocalStack here. And meanwhile, and let's have a look at the Terraform code that does this basically. You can see you have like two resources, a bucket where you put the image and the bucket that receives the image at the end. You have a Lambda specified here. I won't show you the code of the Lambda, but basically what the code does is it takes the image and resizes the image. We have the IAM role for the Lambda to be able to get stuff from a bucket and put stuff into the other bucket. And then you basically, so I think I will need to enlarge the prompt there, saying in the chat. So basically, this last part is the code that it's used to configure the S3 bucket and Lambda. So the trigger when you the trigger that actually triggers when you put an object into the bucket. Let's try to deploy this. This is going to be demo number 2. So you see this is the Terraform module we see now, and LocalStack is running. So let's do an init. We're not looking at the plan now. We just run the init and the apply with auto approve. So we don't need to specify to say yes. Terraform will just go straight. As you see now, it told us the resources that we want to create, and now it's doing stuff. It's creating resources. Probably we see some logs in LocalStack that's creating stuff. Okay, it was easy, so it was fast. So 6 resources have been created. Let's check which resources. So probably there are some buckets. Yes, we can see some buckets. Image bucket is the source bucket, and the other bucket is the bucket that receives the final image. Probably we have some Lambda function that does the translation. Yeah, Lambda function is here. So let's try to put some object in the bucket to see if the Lambda is triggered. So I always have like a Pikachu image for these purposes on my laptop. And let's try to put that into the bucket and see what happens. Okay. So if you see here in the logs, Lambda function has been triggered. This Lambda function was running. And if you see in the output, it says that this image has been uploaded to this bucket. Let's try to list this bucket over here. This was the destination bucket. So this was the original bucket where I put the image. And this other bucket, resize, is the bucket that received the image that was reduced as insights, was moved to a thumbnail. If you want to see the results, you can see, we can download this image from the bucket to your host, and we can open it, and we can see, okay, yeah, this was the image, the thumbnail. And if you want to see the original image, downloads Pikachu. This was the original picture. So it was like reduced insights, basically. Okay, this was the basically what was done by Terraform. Let's try to start playing a bit with pods now. So we have some resources in LocalStack. So we saw we have some S3 buckets. We have some Lambda function. You can interact with pods using our CLI. So if you ask for help for the pod commands, you'll see basically you have two commands available here. You have like a load and save. So save lets you create like a new cloud pod, take a snapshot of what you have, and you save it on disk. And basically loads does the opposite operation. So if we try to see what save tells us, basically saves the current instance of LocalStack in a pod, and it wants you to pass as an argument like a file URI with the path on disk. And it will basically save like a snapshot of LocalStack on this path to disk. We can try to actually do it. So I'm passing the path of this directory here, and let's see what happens now. We get a message that the Cloud Pods has been saved at this path here. And if you look in here, we can see this file here, pod. This is what was the name of the pod we created. And if you want to look at inside this, this is actually a zip file that contains all the state of LocalStack. If you just want to, if you're curious and want to know what's in there, you're going to find like a lot of this file that these are basically a pickle representation of the backend running in LocalStack. What we do with pods, basically, we just like take the backend in LocalStack, we pickle it down to disk to be able to load it later. Okay, now let's try to stop LocalStack to have like a clean state, and then restart it again. LocalStack is starting again. Takes a second. And now let's try to load what we said before. If you get the help for the load command, basically it tells you what you can do. You can basically load the pod for different sources. We want to load from file, so we will just need to tell LocalStack pod load with the file path. Let's try to do that. Pod load file, and this is the path of the pod we exported now. And it's trying to load it up. It says that we were able to do it successfully. If you see here, we get like confirmation that the pod was done correctly. And let's try to list some resources. So we have two buckets as before. We should have the Lambda function listed here. And if we do, we can basically try to do the same operation that we did before to put like a Pikachu image, and we should basically be able to have again the image here. So basically we were able to restore the same state like we did with Terraform, but with the pod. So instead of like using Terraform to spin up our resources, we were able to just like basically use Cloud Pods to achieve the same results. And you might want to ask yourself, okay, well, why do we use Cloud Pods if you can do like similar stuff with Terraform or with Pulumi or with whatever? And I'm gonna show you like one of the reasons why in a moment with like a bit more of a complex state. But let's say with Pod, what you cannot do with like this other infrastructure as code tool is to basically have deep collaborations and be able to share those instances across team members. So if I will just give this pod file to a colleague of mine working in LocalStack, you can just basically do the same operation, inject the state into his version of LocalStack, and basically have the same state that I'm having now at this moment in my LocalStack instance. And this is very powerful for collaboration, for debugging, and for a lot of use cases. I show you this example here now, but I want you to move to an even more complex example. And this is going to be my last one for today. So start LocalStack from a fresh instance, and I go with demo number 3. So in this third demo, we are having basically this application deployed with Terraform. This is like a bit more complex. I don't want to go in extreme details, but basically here we have some API gateway that expose some 2 containerized services, and they basically are hosted into ECS, and they read and write data to DynamoDB tables, and like authentication is done via Cognito. And we have a Terraform script to deploy this as well. Let's try to run it now. It's again tf local init and apply auto approve. So this is like a bit more complex Terraform module. So probably it's gonna take like a bit longer to be created. If you see, it has like 57 resources to be added, and so let's see how long it's gonna take. If you can see, it's doing stuff in LocalStack. It's creating resources. You can see the different logs, and it's moving. Let's wait for a few seconds more. I should probably prepare some stories while waiting for the scripts to execute. Okay, the resources have been created, and so everything we needed, that we see in this picture, has been basically deployed. We have a little front end that basically helps navigate this application. So I have like a small script to deploy it. So I'm just gonna run it now. So basically it takes like a small node application that basically let us navigate the state. I will show it in a second. This has been deployed to S3 bucket. You're gonna take the link and navigate to this link over there. Okay, this is like our application running, the stuff we have deployed with Terraform. We proceed, and basically what we have now, so let me get a bit bigger. So we have this application that exposes 2 APIs. We can put and get stuff from it, and we can do a get without being logged in, but we need to log in if you want to put stuff in there. So what we put in the via this API goes into a DynamoDB table. So let's try to sign it first. I need to probably create an account. So let's put my email, LocalStack.cloud, and a password. And it wants a code that you can grasp from the logs of LocalStack. This is the code to confirm. And let's try to confirm. Okay, we are in. So let's try, for instance, like if you try to have a get call in one of those endpoints, of course you get nothing because you didn't put anything in this endpoint. Let's try to put some stuff in the endpoint. So I just put like a test JSON in there. Okay, it seemed that worked. We see in the logs of LocalStack the caller reached the correct endpoint, and it tells us that this JSON has been put correctly. And if we try to not to get it, we should see the correct output C. If we ask for get for this ID, we get the right data here. And of course, if you want to test this application, let's say you deploy it and you want to test the get, of course you will need to first put something in there. And you cannot, like, if let's imagine you have like some test that test this simple application. You will need some data to be allowed to run automatic tests on this. So you need to precede your test environment to be able to test like deeply this this application. And like in this scenario, I can show you how Cloud Pods can help. Let's try to put like a few more stuff in there. We put something else, and so we probably need to do this. Put 3. Okay. Let's look now. So when we said that when we put to this endpoint writes this data to a DynamoDB table. So if you just list the DynamoDB table that we have here running, we probably find 2 tables. Let me run it again. So we had 2 tables, one for the one endpoint, one for the other endpoint. So we put stuff in this first endpoint, food store, food endpoint. So let's try to see what's in this table. DynamoDB scan table, food store. We see, okay, that you can find in there what we put so far into the table. All the objects we put so far. We have 3 objects. With Cloud Pod, we could try to take a snapshot of this application, but instead of taking like the full snapshot or like all resources, we have seen before, we have like 57-ish resources. Instead of doing like full snapshot, we can just take a snapshot of only DynamoDB table. Why do you want to do this? You want to do this because if in a later moment you want to test this application and you spin it up and you want to test the get method, you want to inject some test data to be able to retrieve something from the get endpoint. So in a testing scenario, you spin up this application, you inject only the pod containing the DynamoDB table, and you will be able to straight away to use the get endpoint to retrieve stuff. This is like one of the use cases that pods enable. To be able to do this, let's first log in. So right now I have like this is my LocalStack account. So let me try to log in. And list the pod save command. So what's if you remember the description of the command changed a bit. What did I do now? So before I was not logged in. So to log in, you need to have a valid license for LocalStack, and you have some additional feature for the save command. So before, without being logged in, every community user can save like a snapshot of a pod to a file on disk. If you are logged in, so if you're a pro user, you can do this, plus you can use our platform. So basically, when you save a pod, you don't specify a path anymore on disk, but you just say a name of the pod you want to create. And this basically, what it does it's created and it goes to our platform, and we manage versions of pods for you. So we store them, we make sure that those are shared amongst your colleagues, amongst your organization. And furthermore, we also add like possibility to select only subset of services you want to snapshot with pods. In fact, if you see here, you have like options for this command. You have services option. You can pass a list of services to save in the Cloud Pods. So let's see this in action. So if we type LocalStack pod save, let's say meetup DynamoDB, and then you say services, and you say DynamoDB. What this does, it basically creates a pod called meetup DynamoDB only with the DynamoDB data. So it doesn't care of this API gateway of Cognito that you have in this application, and it saves it up to our platform. And this is then available for other people to download, for your colleagues to download, for you to download in a later moment. Let's wait for a second. This might take a second. Okay, it says that Cloud Pod Meetup DTB has been created. To make sure, let's try to stop LocalStack again. To have like a fresh instance of LocalStack. And let's start it here once more. Starting again. So if we list the DynamoDB table here, we get nothing basically. Let's see, LocalStack starting LocalStack. We get nothing. Let's try to load this pod and see what happens. See, here is doing stuff with DynamoDB, it's starting the service. Now, if we list this table, we have the two tables as before. Only those two tables. We don't have any more service running in LocalStack, but those DynamoDB tables. And if we actually scan the table again, what you see is exactly the same data we had before. So ideally now, if you spin up the entire application, like we did before with Terraform, you can immediately run some get API call because you already have the data in there. And this is like one of the examples of that we believe, where we believe Cloud Pods shine. So we can precede application with some real data. And from basically, I mean, I'm interacting only with the CLI with pods, but we have like also our website where we can list pods. And you should probably be able to, this is like a bunch of pods that I created like in the past. You can see here, you can look at them here. You can see how many versions they have, because through this UI, you can manage versions. You can actually select the pod and try to inject a pod from here. You can delete it, and you can do like a bunch of stuff from the UI. And those pods are shared across your organization. So you can basically give a pod to a colleague of yours. As you can see here, you have like the meetup DDB pod I just created, and this is the size of the pod. Yep, I think I went through all I wanted to show. I didn't follow up the chat if there were some questions, but if there are some, I'm happy to take them.
There are a bunch of questions in Slido, if you want to check that out.
Okay.
Joe, would you like me to present the screen?
Yeah, please.
Yep. I guess the first comment is like the speed of the Terraform apply here is much faster than deploying to AWS.
Yeah, I mean that's one of the advantages of LocalStack overall. Of course, it's gonna be much faster, and yeah, it's gonna take much less time. This is yeah one of the good selling point of LocalStack. And for the second question, yes, we have something for Pulumi as well, and we have wrappers for most of this infrastructure as code tools. I'm pretty sure there is one for Pulumi, and we offer it for I guess most of the most used ones. Awesome. You don't need to spend time to configure your endpoints.
Are the cloud pods stored in the cloud or in my local machine? I guess you have pretty much covered that by showcasing the LocalStack Pro. So I guess, yeah, if you're using cloud pods on your local machine, you can just use a file URI as an argument so that you can save it on your local machine itself. And we also support Git-based backends, so you can store it on your GitHub or maybe even GitLab repositories, and you can just download the cloud pods through that itself. Otherwise, if you're a LocalStack Pro user, I guess you will be able to store the cloud pods on the LocalStack application itself, and then use it to share it across with your teammates.
Yeah, exactly. So basically, with the community version, you can store pods locally. You need to take care of like storing them somewhere. You can still share them manually with like coworkers in a easy way.
Yeah. Is there any performance regression between LocalStack and real AWS while using Terraform?
What do you mean by performance regression in this context?
I believe they might be asking like, is it fast or is it slow or something around that?
I mean, like, of course, like if it's on LocalStack, it's emulated on your local machine. It's gonna be slower. There might be some parity issues now and there with LocalStack, of course, but we are fixing this as we speak. Actually, for the latest example I showed to you, like we found out like a small issues. We fixed it for at 100% parity with AWS when it comes to deployed Terraform modules.
Awesome. Cool. I guess we have a few questions left here. Is there a little web graphical user interface to list created resources on LocalStack? I guess you can only use the LocalStack web application for this. And if you have an API key configured, you can get to see all of the resources that we have created already. And we have something that is called as the resource browsers. We are further developing that. So let's say you have created some S3 buckets or some Lambda functions. You can go to the specific service-oriented resource browsers, and you can just list down all of those resources out. And yes, website right now is only for the pro version, but we are building out something for the community as well. Cool. Is EMR on EK service supported on LocalStack? So for all of these supported issues, I guess our docs provides us a very comprehensive overview. So you can go to docs.localstack.cloud and you can actually check like which of the services are being supported. And you can also check out all of the APIs that are a part of the coverage support, along with like which APIs are a part of the community edition and which APIs are part of the pro version. So yeah, thanks Silvio for linking this out. Yeah, I guess there is a separate document for the API coverage as well. I guess I can just mention that over here, and I hope that's useful. And yes, the code is available on GitHub repository. I guess I'll just link it with the YouTube video when we publish that on our channel, so you can easily check that out. Or you can go to the github.com/localstack/presentations, and you can just find out the code over there. Cool. So do we want to go on with more questions? Because I guess we are already over time and we needed to showcase the Docker extension.
Yeah, you can like maybe just let me take like this question about complex Terraform states. I mean, the latest one I deployed, it's like a fully fledged application with Cognito, with API endpoints, with 2 Docker images running. So I count that as a fairly complex application. Of course, there's going to be always some small issues that can come up, some parity issues, but yeah, we are we are fixing this quite quickly as we progress with our implementation. For the pod state file size, like locally there is no limits. Cloud Pods are still like a feature under heavy development. So we never experienced so far like huge pods sizes. But if you come up with some particular use cases and you find out that you are having issues with some large sizes of pods, you can reach to us, and we will be happy to look at the different use cases.
And I guess regarding the auto-loading a pod from Docker Compose, I guess that's not a possibility right now because Docker Compose only provides a way for you to start your LocalStack container with all of the different configuration options. You might still need to use the LocalStack pod CLI to use this, and it is entirely shipped with the LocalStack CLI itself.
Yeah, exactly.
Awesome. Cool. So I guess I'll just go over my part really quick. So really trying to improvise over this. So won't be going much onto the slides and everything. I'll just jump directly into the entire demonstration. So I hope my screen is visible right now. Yeah, a lot of poppers over here. Cool. So thanks everyone for sticking with us till this. And I guess we are shooting over the time, but yeah, we can accommodate like a really short session on the Docker desktop extension. So so what exactly are Docker extensions? So Docker has been working upon the extensions for almost a year over now. And Docker extensions are basically tools that can allow you to integrate various third-party toolings, software, and the other products directly into your Docker desktop. So for a lot of people who have been using Docker on, let's say, Windows or maybe Mac, you might already be familiar with how Docker desktop works out. And even though it has some restrictions on the people like who are using a free version, it still provides a lot of great functionality for you to control your containers, your images. And with the help of the extensions as a new product now, you can also integrate these toolings into the whole Docker desktop scenario. So right now, Docker desktop is currently supporting over 30 plus extensions. So a lot of good extensions are over there, like disk usage, Lock Explorer, and even some third-party toolings like Drone CI. I guess we had one of the sessions where we talked about how to work around with LocalStack using Drone CI. We have got Sneak, which is used for image scanning, and many more. So if you want to check out what are all the Docker extensions that you can basically play out with, you can just go to the Docker desktop, and you can click on the add extensions, or basically you can also go on and just browse the different extensions that are present over here. So LocalStack happens to be one of the extensions, and we just released out almost this month itself. And apart from this, we have various new extensions coming out from a lot of different companies, dev tools, and different like startups altogether. Cool. So how does LocalStack and Docker play out together? I guess one of the strongest foundations that we have within LocalStack is that we're shipping out our entire local AWS evaluation as a Docker image itself. So anyone who exactly wants to use LocalStack, they can just pull our Docker image. They can create a Docker-based configuration or a Docker Compose-based configuration, or they can just use the LocalStack CLI to control your Docker container entirely. So right now, the CLI is a very handy way for you to control your LocalStack container. So I guess Joe already showcased like how you can start your LocalStack container, how you can stop your LocalStack container, and how you can check out the logs and all of these things. And with the help of the Docker extension, we basically allow the users to do all of this in a nice visual manner. Apart from this, we also provide a lot of different visual functionalities. You get a way to inspect all of the services that are running as part of your local emulation. You get to see the LocalStack logs so that you can easily debug your application, or if some particular APIs are not working out altogether. And you can also create multiple profiles for yourself using the configuration option that we provide. For example, let us say you just want to use the LocalStack community image right now. So you can use the default profile itself, but let us say you have a API key, you're basically a licensed user right now. So you can create a separate profile for yourself where you can configure your LocalStack API key, and you can get started with using LocalStack for your purpose. So this provides a really handy way for you to get started with LocalStack without ever going onto the terminal. I'm sure like a lot of people basically hate going through the terminal and configuring a lot of different options out there, but a lot of people, including me, just like to use the CLI itself. But the Docker extension is a really great means for people like who just want to do things in a visual manner. So how exactly can you go about installing the Docker extension for LocalStack? I guess that's pretty easy. And maybe the first step that you can possibly take is to download the Docker desktop. If you are not allowed to download the Docker desktop because you are on some corporate network, maybe you can look into completely different toolings altogether. For example, we have an entirely different desktop application that is called Cockpit, and it provides nearly the same functionalities that we are providing as part of the Docker extension. If you're a Docker desktop user, the very first step that you can possibly take is to go to the preferences. And this will actually list out an option that is called as the extensions. So you can click upon the extensions, and you can basically enable the Docker extensions as part of your Docker desktop setup. So since I've already done that, you can already see that it has been checkmarked. But if you have never done that before, you might need to checkmark this, and you need to restart the entire Docker desktop so that you get this option visible. So once that happens, what you can do is that you can go to the extensions marketplace. So it contains, like, it's a holistic list of all of the extensions that are part of the Docker desktop product. And you can get to see like the different extensions that are available over here. Some of these extensions are pretty niche and quite great for personal use cases. For example, I use the disk usage quite a lot because I need to check what Docker images are staying on my machine for a long time and they have not been used for a very long period altogether. So over here, you might get to see the LocalStack extension as well. So the very first thing that you can actually do is to check out like how this works out. And you can take the first step in installing this particular extension. So what it will actually do is like it will pull this particular Docker desktop image from the Docker Hub registry that we have. And once it is pulled, it will configure a few other details. And with this, the LocalStack extensions will be installed successfully. So you can go to LocalStack, and the very first step that you will be taking over here is to actually select where LocalStack will be mounted. So we need to select a mount volume over here so that LocalStack can be mounted over that itself. And if you're a Mac OS user, it will be happening under users/shared/.localstack-volume. For Linux and Windows users, it will be under home shared.localstack-volume. So we have already made this simplified. So all that you need to do is to select your user profile over here, and the extension will basically take care of the rest. So this is how the LocalStack extension looks like. And it provides a lot of nice visual layer about how you can go about managing your LocalStack instance and how you can go about selecting different things altogether over here. I hope I'm audible right now because I don't see anyone. Yeah, cool. So if you want to start LocalStack for the very first time, you can just go about and click on Start. And this will start LocalStack container. And once it has started, you can basically maybe just refresh this option and you can get to see all of the different services that are available with this. So LocalStack supports almost 75 to 80 services along with some sub-services that are already part of the primary service. The reason why you don't see some of the services over here is because I'm starting a community image, and LocalStack extension is completely free for community usage. So you don't ever have to pay anything for this. And some of the services which are not available over here are basically under the professional purview. So you might need to set up an API key and you need to start LocalStack with that if you really want to use that particular service. We also have the configuration option, and this is where you can actually change the mount point over where LocalStack is basically mounted. And you can also go about and create a new configuration profile for yourself. So let us say I want to create a configuration profile for my professional use cases. I can maybe set the configuration name as pro, and I can set different variables over here. Like I can say debug is equal to 1, and maybe I can also try to add a LocalStack API key if I'm a professional user. And this will allow me to basically start LocalStack using this particular configuration itself. But apart from this, we also have the logs running over here. So you don't have to manually type in LocalStack logs every time if you want to check out the logs. And it is really quick. So if I can just go on my terminal and let us say I'm just doing aws s3 ls. Since I've not created any bucket before, it will not actually show us anything over here. But if you actually go onto the logs, you will see that LocalStack is already making some API requests, and you will get to see the status responses over here. So this is pretty much how LocalStack is working out with the Docker extension. And all of the AWS resources that you're creating over here is ephemeral in nature. So if you just shut down this instance right now, it will basically stop the LocalStack. All of the resources that you have created already will be completely vanished, and you can just completely start from a clean slate altogether. So that's pretty much how the LocalStack extension works out. I wanted to showcase a demonstration, but since we have already went over the time, I guess I will just skip that from this meetup. And maybe in the next meetup, we can particularly discuss about that along with some of the nice integrations that we have been working on. So that was pretty much it regarding the installation. So that was all from my side. So if there are any questions or any comments, maybe you can put that on the chat, or we have the Slido option open right now, so you can just put up all your questions over there. Yeah, thanks, Waldemar, for sharing the Docker extension. So do we have any questions left right now? Okay, I believe not. So just a final point, I guess the LocalStack's Docker extension has already been installed over 2,000 times. So that's quite a big feat for us because we made a launch just 3 weeks back, and we have already got quite of a community adoption. And we further strive to make the Docker extension support more and more new features that a lot of customers will find it useful. For example, Cloud Pods might be something that a lot of people might find useful because they want a really nice visual means so that they can control all of the local Cloud Pods and basically delete them or maybe update them or maybe start from a clean slate altogether. So we are all for participation from the community. So if you want to discuss about the LocalStack Docker extension after this talk, you can go to our discuss forum. It's pretty much open for everyone. And all that you need to do is to create an account on this and just create your threads over here. And we can maybe provide some updates or some suggestions about how you can go about doing it. You can also create an issue if you're interested in contributing to the Docker extension. I guess it's pretty much open source. And the code base is based upon JavaScript and Golang. Or if you want to explore the Docker extension further, or maybe you want to explore more professional support regarding some of the AWS services that we're working on, you can just send us a message on info@localstack.cloud. I guess that was pretty much it, folks. Thanks a lot for joining today. And if there are any further questions, I guess I can take that up. So is there a local or remote Cloud Pods integration for the extension to save state? I guess we don't have a Cloud Pods integration right now, but this is certainly something that we are really exploring out. So maybe in the next release itself, we might get to see an update so that you can actually like check out your local or maybe remote Cloud Pods. And we can also try to see like how we can support the community further with Cloud Pods itself, because it is a growing tool right now. And we really want more and more people to use it, to provide us some suggestions about how we can improve the experience so that we can make it a general platform so that you can easily develop your local cloud applications. Awesome. Waldemar, any final words from your side?
I think you covered really well. So thanks a lot for the demos, both on the Cloud Pod side and the Docker extension. So again, great to have you all in the community. Great presentations, and looking forward to the next events and everything that's coming in the next year.
Awesome. There has been one question about is LocalStack Cockpit a standalone version of the Docker extension? I guess there is a significant overlap with regards to the features that we have been working on. So I would say yes, it's a significant overlap. And if you don't have the liberty of using the Docker desktop, you can easily check out Cockpit and you can use the similar features over there as well. And this was one of the primary inspirations that we used while developing the Docker extension as well. So I can maybe share it over here. It's in beta right now, but we have got some really good feedback from the users who have been using it for quite some time. So definitely give this a shot, and please let us know what your experience has been, and we can further work upon improving this out. Cool. I guess we can close the meetup for the day. So thanks everyone once again. And the recording will be available on our YouTube channel. So if you have not done that before, please subscribe to our channel. And definitely sign up on our meetup page so that we can keep you updated about any of the upcoming meetups, because we have some sincerely good talks lined up for the next few months, and we definitely want you to be a part of it. Cool. Hope you have a great rest of the day, folks, and I'll see you the next time. Bye.